Welcome students. In this lecture, we see the variable resistor, capacitor and inductor. Previous lecture, we studied fixed resistors. First, variable resistor. Variable resistor are resistors that change resistance from 0 to certain maximum value. They are commonly used as a volume control and in voltage regulator. See, these are the symbols of variable resistor. Variable resistor are of three types: potentiometer, rheostat, and present. This is the standard symbol. First is a potentiometer. The potentiometer is a three terminals. Here, these are the three terminals resistor in which the resistance is manually varied to control the flow of electric current. Potentiometer control the flow of electric current. These are the symbols: American Standard zigzag lines with three terminals, American Standard symbol. This is the International Standard symbol, rectangle with three terminals. See this diagram? In this diagram, three terminals here. The potentiometer consists three terminals, among which two are fixed. Two terminals are fixed and one is variable. The two fixed terminals of the potentiometer are connected to both ends of the resistive element called track. And third terminal is connected to sliding wiper. The wiper that moves along the resistive element varies the resistance of the potentiometer. The resistance of the potentiometer is a change when wiper moved over the resistive path. Next is a restart resistor. Restart is a variable resistor which is used to control the flow of electric current by manually increasing or decreasing the resistance. See the symbols of restart resistor. American Standard symbol with zigzag lines with three terminals, semi rectangle with three terminals. Here, construction of restart is almost similar to the potentiometer. Like a potentiometer, restart also consists three terminals, A, B, and C. Two terminals are fixed. One is variable connected to wiper, and these two terminals are connected to the resistive element. End of the resistive element is called track. Okay. The B is the variable terminal connected to the wiper. The wiper that moves along the resistive element varies the resistance of the restart. The resistance of the restart is a change when the slider or wiper resistive moved over the resistive path. Next is a present resistor or present potentiometer, or you can say trimmer also. This is the micro version of the variable resistor. Present resistor are directly mounted on the circuit board and adjust only when the circuit is built. There is an adjustable screw attached to the resistor, and a small screwdriver is required to adjust this screw for the desired resistance value. The carbon composition and wire wound element are used in the present potentiometer or trimmer. The adjustable variation of the resistance is possible up to fraction of an ohm, which is done by rarely with a screwdriver. Now next is a capacitor. Capacitor store the electric energy. This pool of electrons is available for electronic component to use. Capacitor is measured in farad. The small capacitor usually used in electronic are often measured in microfarad and nanofarad. Now we see the type of capacitor. First is a mica capacitor constructed from plate of aluminum foil separated by sheet mica. Plates are connected to two electrodes. The stacked mica capacitor are made of thin mica sheets arranged one over another, and each mica sheet would be separated by foil, thin metal foil or sheet of copper or aluminium. The entire unit is enclosed in plastic case to protect it from mechanical damage and moisture. The terminals are connected at each end of mica capacitor. The mica sheet placed between the metal sheet act as a dielectric that oppose the flow of electric current, and copper or aluminum sheet act as a die. Copper or aluminum sheet, these are the sheets, act as a dielectrodes. Now next is a ceramic capacitor, a fixed value capacitor where the ceramic material. Here, this capacitor is constructed from ceramic material, and this ceramic material act as a dielectric. These are often used as a safety capacitor in electromagnetic interference suppression applications. This dielectric, because the ceramic material is chosen as a dielectric because of its great ability to flow of electrostatic attraction and repulsion. Also, ceramic material are poor conductor of electricity. Therefore, they do not allow the flow of electric charges through them. On the other hand, electrodes of the ceramic capacitor are good conductor of electricity. Therefore, they easily allow the electric current through them. Next is a paper capacitor. Paper capacitor is a capacitor that uses paper as the dielectric to store the electric charge. Here in paper capacitor, use the paper as the dielectric to store the electric charge. It consists of aluminum sheet. See here, this is the aluminum sheet and paper sheet. The paper sheet is covered or soaked with oil or wax to protect it from outside harmful environment. Next is a electrolytic capacitor. An electrolytic capacitor is a type of capacitor that uses the electrolyte, ionic conducting liquid, as one of its conducting plates to achieve a large capacitance or high charge. A capacitor is a electronic device that stores the electric charge. It consists of two conductive plates. Here, two conductive plates separated by insulating material called dielectric. Different type of insulating material are used for the constructing the dielectric based on the usage. The conductive plates of the capacitor are good conductor of electricity. Therefore, they easily allow the electric current through them. On the other hand, a dielectric medium or material is a poor conductor of electricity. Therefore, it does not allow the electric current through it. After that, see a variable capacitor. The variable capacitor are frequently used in different applications due to their simple construction. See here, generally these capacitors are made of two set of hemispherical metal plates. Two sets of hemispherical metal plates which are divided through air gap. Which are divided through air gap. Now next you see the inductor. Inductor an inductor is a particular chalk or coil which has a which has two terminal structure, and it utilized to build different circuits. The basic performance of the inductor is the energy storage in the magnetic field. It includes a wire typically assembled as a coil. If current moves within this coil, it can be stored in that coil. A perfect inductor operates like a short circuit to di- direct the current and provide an alternative force that is based on the frequency of current. The condition of current flow of an inductor is proportional to the frequency of that current through it. These instruments are introduced as a coil because most of their construction is a model based on the section of wire and coil. Next is a transformer. A transformer is a device used in the power transmission of electric energy. The transmission current is AC. This AC means alternating current. It is commonly used to increase or decrease the supply voltage without a change in the frequency of AC between circuits. The transformer work on the basic principle of electromagnetic induction and mutual induction. See here, the transformer turn ratio is a NP divided by NS equals to NP VP divided by VS. See here, NP is a number of turn in primary and S equals to number of turn in secondary. V means VP means primary voltage, P means voltage, and means number of turns. So here PS is the secondary voltage. So the transformer turn ratio NP divided by NS equals to VP divided by VS equals to N equals to turn ratio. If a voltage transformer has 1500 turns of wire on its primary coil and 500 turns of wire for its secondary coil, what will be the turn ratio? It is TR of the transformer. This ratio is 3:1. Simply means that there are 3 primary winding for every 1 secondary winding. As the ratio move from a larger number on the left to smaller number on the right, the primary voltage is therefore stepped down in value as shown. Okay, this is the TR, it is turn ratio. So thank you, student. Next lecture we see the semiconductor devices and tube devices. This is active component. Okay. So next lecture we discuss on active components.